We're going to talk about equivalent equations really quick and then jump to the addition property of equality. Two equations, let me just give you the definition, are said to be equivalent, and this is in your book. Two equations are said to be equivalent if every solution of either one of the equations is also the solution of the other equation. What it means is whatever number satisfies this has to satisfy this as well for them to be equivalent. So let's just check. What number satisfies this? What does x have to equal to make this side equal to 9? X must equal 3, right? Well, let's look over here. Oh, x needs to equal 3 as well. So since x equals 3 on both of these, then they are equivalent. Equivalent equations because they have the same solution set or same solutions. All right, the additive property of equality. What I'm showing you, I'm going to show you here, is I've got an equation, 2 equals true, it's true. So what I could do to this side, what if I add 3 to that side? And if I do that, but I also have to add 3 to both sides to make it legal. If I do add 3 to both sides, the equation still is true. So when you add the same number to both sides of an equation, it does not change whether or not they are still equal. They still remain equal. Okay, any number I add here, or if I add a negative, okay, what if it was this, and we added -5 to both sides, plus -5, what do we get? We get -3 equals -3, and it's still true. So we can do that in equations. They're balanced as long as we do it the same thing to both sides of the equation. So here's the fancy definition of that. If A and B, or A, B, and C are any real numbers, and if A equals B, then A plus C equals B plus C, and also C plus A equals C plus B. Now that is weird, but we really just showed it up here. What they're saying is if A and B are the same number, okay, they equal each other, which is what I said up here. Let's say A is 2 and B is 2. Okay, then, and let's say A is, in this case, A and B were 2, and C was +3. So they're saying when you add C, add the same number to both sides, they still remain equal. Here they just changed the order of things. So these two are almost exact statements. Okay, what does this all mean and how do we use it? Well, it's how we solve equations. We're going back to pre-algebra where we started this. We want to get x by itself. Okay, so this is how we do that. We want to get x by itself so we can find its value or find the root. In order to do that, we need to get rid of this thing, the +4. So in order to do that, if we want to get x alone, we add -4, right? Or subtract 4. They mean the same thing. Add -4 is the same as subtracting 4, but in order to do it, we have to balance it out by doing it to both sides to make it fair and equal and balanced. So when we do that, we get, these go away, really, you can see this, x plus 0. I'm going to show it with the training wheels, equals 2. And now x plus 0, we can just get rid of that 0 and say x equals 2. Now, yeah, you could have looked at this already and said, Mrs. Dashiell, it was so obvious. I didn't need to go through all that work to tell you that x equals 2. Obviously it does, because 2 plus 4 is 6. I agree. But it's not always going to be so simple. We're going to get some heavy-duty equations as we go along. So we need to know the step process. And this might bug you when you like to not show your work and just jump to the answer. So this is going to be a challenge for you, not comfortable. Now here I wrote check. When I get x equals something, it's good to go back and check and see if it works. That way when you turn in a test, you already know if your answers are correct when it comes to solving equations. So to check, we see if this truly does satisfy the equation. And see if it comes out true. So yes, it worked. So that's how we do an equation and then check to see if it was true, or check it, okay? This is an interesting statement, and you're going to see it again in the next lesson or so. If the same quantity is added to both sides of an equation, which is what we did, right? The same quantity is added to both sides of an equation, the resulting equation will be an equivalent equation to the original equation. So they're saying nothing changed. These stay equivalent. So now I have x equals 2 was an equivalent equation to this. So what they're saying is we can manipulate equations legally without ruining, without messing anything up. And thus every solution of one of these equations will always be a solution of the other equation. Okay, so basically this is a mathematical, or a way to explain what we just did mathematically by using an English paragraph. Okay, so let's do this again. Let's solve. We want to get x by itself. Now you might be looking at it and go, oh, well, I know 15 minus 3 is 12. So can we just be done? Well, no, we can't. We have to actually go through the process because, like I said, it's not going to be this simple for much longer. So let's make sure we know what we're doing. So if I want to get x by itself, I'm going to add 3 because these two then turn into a 0 and cancel each other out. So that x will be the only thing down there when we're done. Now, in order to do that, I have to, like I said, we have to add it to both sides of the equation so that they remain equivalent, right? So here we are, x equals 15. And remember how we can check to see if 15 is truly a root? Again, we're starting with obvious ones so that you can get the process down. All right, and I always like to box my final answer there. All right, so this is fun. Now you see a fraction. Fractions might not be your favorite thing. They weren't for me at the beginning, but now I love them. So let's go ahead and get x by itself. Well, we have to get rid of that 1/4. So let's subtract 1/4 from both sides. These cancel out. That'll turn into a 0, so x is left on the left side. 3/8 minus 1/4. Now we can't just do that. We actually have to change the denominator because they do not have the same denominator. So what we need to do is make an equivalent fraction for this. 1/4 is the same as 2/8. So we have 3/8 minus 2/8. Now two negatives, we're going to have a negative answer because we're adding and subtracting. We get negative 5/8. And that's our answer. Could we check that? Absolutely. I would plug it back in to the equation and see if it works. Again, this needs to be eighths, so 1/4, so maybe we would write it this way. 1/4 is 2/8, and negative 5 plus 2 is negative 3. And that's true, so we got the right answer is what we just found out, right? Example 3, again, more fractions, super fun. Now what I like to do with these is if I have a mixed number here, I know that there's going to be some adding and subtracting. So I'm going to change this into an improper fraction right away and rewrite this as k plus, remember how we do this? 3 times 2 plus 1. So that's 6/7 equal to 9ths. And now we solve it this way. It's going to be a lot easier. Subtract 7/3 from both sides. See what's left. Those guys go away. We have our k. And a positive, oh, they're not, sorry. These are not the same denominator. So I'm going to have this one move to a 9 for a denominator. So that's going to be a negative 21. Isn't it? So now we have 2/9, negative 21/9. So it's going to be negative. 9ths are on the bottom. Negative 19/9. Now here's the good news. We do need to reduce if we can, which this cannot. but we do not need to change this into a mixed number. You do not need to change this to -2 1/9. We can leave it like this. I was happy about that when I got into algebra, that we can leave fractions like that. So can we check that? Yes. -19/9. Now I'm going to use the improper fraction to check that and see if this works. Okay, well, this has to change to ninths, and like we already had decided, that was 21/9, and 21 minus 19 is +2/9. So yes, we have the correct. Oh, I don't know why I'm writing false. I'm thinking true, but writing false. That is true. So it worked. Here we are with your practice. Go ahead and try it. If you get stuck, come back on and watch. All right. So I'm going to go ahead and subtract 5 from both sides, or add -5, and we get x equals 12. Now I could check it up here. I'm going to show the checking. Now, am I going to force checking? No, but it's certainly a good way to make sure that you got the right answer. And then you go, oh, okay, I know this one's right, Mrs. DeShiel. So I already know I got an A on that problem if this was a test, right? Or got full credit. All right, this time we're going to add 27 to get rid of what's over here. And I'm going to get, what is that? 11. I'm going to get -11, okay? And then I'm going to try it to check and see what we get. -11, yes, -38. And it's true, so we know that the answer is correct. Okay, add 1/2 to both sides, and we get x equals 3/8 plus 1/2. Well, I'm going to change that to 8s. So 3/8 plus 4/8 is 7/8. And then, yes, let me go ahead and check that. Is 7/8 minus 1/2 equal 3/8? Well, let's do 1/2 into 8s. We said it was 4/8. And yes, it works. So when I turn this in, it says x equals 7/8. I'm going to know I did it correctly. All right, one with fractions. Again, I'm going to change all these to improper. So that's 29/7 equals 6 times 3 plus 1 is 19/6. All right, so I can tell we're going to have to give these some common denominators. So you might possibly not enjoy this one. All right, so we're going to subtract 29/7 from both sides, and we get, all right, now we're going to have to change the denominator on both of these. Now 6 and 7, the only common denominator I can think of that they have. Well, this one's going to be ugly. I feel like I must have written it down wrong. Nope, I think it's correct. So it is going to be big and ugly, and that's okay. Don't be scared. I am making sure that 6 and 7, the only thing they can go into I can think of is 42. And unfortunately, that is it. So they're going to turn into 42s. Let's see what we get. 7 goes into 42 6 times. So now I'm going to have to do 6 times 29. That's not fun, right? That's why I hesitated. This probably would be not my favorite. So down here, I just did a little 6 times 29. I got 174. And at this point, when you're doing a problem like this, you might be wondering if you're on a rabbit trail and doing the wrong thing. I did. I'm nervous, so. But let's go ahead and try. I can always check and see at the end if I'm done. So 7 times 19 I'm going to have to do now. And that's okay. And I got 133. So now we've got 133 and a minus 174. So I'm going to go ahead and do some math on that down below. I got 41. 41. And that, when I get, now I'm thinking, yes, this is going to be the right answer. -41 over 42 is what we want. That's reasonable to me just because this is a kind of answer I could see the book giving us. I've been a math teacher for long enough. But let's go ahead and try this. Negative 41, 42s. Now we've already converted the this to 29/7, which is 174 40-seconds. So could we just say that? Okay. And then we've already converted 316 to 19/6, which is 133 40-seconds. All right, now we just need to know if 74 minus 41 is 133. And yes, it is. So we get, even though it was a bit longer of a problem, do we have the right answer? Yes. So true, I'm going to be happy with this question. Yes, it did take, I'm going to show you, some work. I had to do some, that's okay. It's still beautiful. I love to see all this math with the answer circled like a beacon of hope. So that is it.